Okay, so you'll have to bear with me as I hold my phone and write. Okay, so let's do number 3. So this says potassium chlorate plus heat. So all this heat is telling me is that it's added to the reaction in order to get it started. So what I'm looking at is my one compound that I'm starting off with. So when I start out with one compound, I know immediately that it is going to be decomposition. So I just have to look at my rule number. And rule number 4 tells me metallic chlorates. So my metal is potassium, and I have a chlorate ion, decomposes into a metallic chloride and oxygen. So I know my metal is potassium, and the chloride just means that it is a chlorine ion. Okay. To make sure my formula is correct, I know potassium has a +1 oxidation number. Chlorine has a -1 oxidation number. So if I crisscross, then I end up with my KCl, just as I had written. The last part of my product is going to be oxygen, but I can't just leave it as a O because oxygen is a diatomic element, so I have to add in my subscript 2 to show that it's diatomic. Last, I just have to make sure it's balanced. So I can write it all out by counting up my ions and then determining what I need to multiply, or I can just kind of look at each element individually. So my oxygens, I have 2 over here, but I have 3 here. So my least common multiple is 6. To get 6, I need to multiply this oxygen by 3. To get 6, I need to multiply this oxygen by 2. Now I have 2 potassium and 2 chlorine because of this coefficient. So I need a 2 right here in front of this compound. So that is my final balanced equation, but I still have to write my word equation. So I'm just going to name everything I have written. So this is potassium chlorate, potassium chloride plus oxygen. And I know this isn't plus oxide or dioxide because the only time I use the ending "ide" or a prefix is if I have a compound. Oxygen is a pure element. Even though it's 2 oxygens bonded together, it's still a pure element, not a compound. It doesn't have, a compound has to have 2 or more elements in it. So I just write this as oxygen. And it even says so in my rules. So it says metallic chloride and oxygen. So really, to name my compound, all I really had to do was determine what my metal was. In this case, it was potassium. Number 4, is it synthesis or decomposition? So I'm starting out with 2 elements, so I know right away that it has to be synthesis. When determining my rules, all of my rules talk about oxides except for number 1. So this is rule number 1, combination of elements. So when these combine together, I have to look at their oxidation numbers before I can write a compound. So zinc is 2 plus, oxygen is 2 minus, and I just got that from my reference table, which is located in the back of your lab manual on page 132. So these are going to cross, so I end up with zinc 2O2, but just like in math, you have to reduce or simplify your subscripts. So I can't leave it like that. I have to reduce my 2's to 1's, and 1's are invisible, so I don't have to write them. So my product is just zinc oxide. So now, let me mark through these so you don't get confused. So now I just have to write my word formula. So Zn is zinc, zinc plus oxygen zinc oxide. So again, this is oxygen, not dioxide, because it is a pure element, not a compound. Alrighty, number 5, I have to use some nomenclature rules. So beryllium silicate, so I have to write this out. So beryllium is Be. Silicate is on my polyatomic ion sheet is SiO3 2 minus. SiO3, and it's a 2 minus. Okay, beryllium from my sheet is 2 plus. So when I do my crisscross rule, I'm going to end up with 2's on the bottom, but they're going to cancel out. So I write my formula just like that. Heated is just telling me the reaction is getting started. I'm starting with one compound, so that means I'm going to have a decomposition reaction. And my rule number that I'm going to use is going to be number 5, because it just says that some compounds decompose into their basic elements. So I don't have any kind of acid, I don't have a hydroxide, and I don't have carbonates or chlorates. So I can rule out every rule except for number 5. Okay, so it's just going to decompose into its elements. So what's the first element that I have? Beryllium. What's the second element that I have? Silicon. What's the third element that I have? O2. Remember, oxygen's diatomic. I cannot write just O. So my final step to look and see if it's balanced, which it is not, because my oxygens do not equal. So I am going to multiply this oxygen by 3 so I can get 6. I'm going to multiply this compound by 2 so that I can get 6 oxygens. But now I have 2 berylliums, and I also have 2 silicons. So that is my final balanced equation. So if I was going to write that out, it would be beryllium silicate yields beryllium plus silicon plus oxygen. So that is the final answer. And again, it was decomposition rule number 5. Number 6, I have zinc and I have oxygen. So I have zinc and I have oxygen. Remember how I have to write oxygen. I can't just write an O, I have to write O2. So I have 2 compounds. Which rule am I going to use? If I'm starting out with 2, it has to be a synthesis reaction, and I just have elements. So it's going to be synthesis number 1. When I combine these together, it's just like number 4. Okay, so this is the same question as number 4. It's just in word form. So my answer is going to be the same. And then my product is called zinc oxide. Okay, number 7, aluminum iodine, is the same as number 1 that we did in class. It's just in word form. So on your test, you're going to have it multiple different ways. So you might have a word, or you might have the compound. All right, number 8, let's look at this. So magnesium oxide, so I know that it's a compound because it ends in oxide. It's 2 elements bonded together. Magnesium is a metal, so it's an ionic compound. So when I write my formula, I have to take into account my oxidation numbers. So magnesium is 2 plus, oxygen is 2 minus. If I do my crisscross rule, remember my 2's are going to reduce. I end up with just magnesium oxide, MgO, plus the formula for water is H2O. Okay, so if I'm only looking at synthesis and decomposition reactions, I am going to, I know this can't be decomposition because it's not one thing, so it must be synthesis. And my rule number 2 says a metal oxide plus water, which is what I have. I have a magnesium oxide plus water is going to yield a base or a metal hydroxide. So my metal is my magnesium. So Mg, and then OH is a hydroxide group, which is again on the polyatomic ion sheet. So hydroxide is OH minus. Magnesium is Mg2 plus. So if I'm going to do my crisscross rule, crisscross. Remember, I cannot leave it like this because this 2 subscript that came from my charge of my magnesium is not only talking about my hydrogen, it is talking about my entire hydroxide group. So I have to use parentheses. So my last step is to check for if it's balanced, which it is not right here. Oh wait, it is, sorry. I missed my formula over here. So 1 oxygen, 2 oxygens. This tells me I have 2 oxygens. I have 2 hydrogens here, 2 hydrogens here, and 1 magnesium, 1 magnesium. So it is balanced. So all I have to do is write my word name. So this is given to me magnesium oxide plus water. So all I have to write is my metal hydroxide. So my metal is magnesium hydroxide. Magnesium hydroxide. Number 9, I have 1 compound, and I'm starting off with, so it's going to be a decomposition reaction. Okay, it's not any type of chlorate or carbonate or acid or base, so it's just going to decompose into its basic elements. So this would be rule number 5. So my 2 elements that make up this compound are hydrogen and oxygen. They're both diatomic. They both have to have 2 subscripts. Now I just have to balance it, but my oxygens are not balanced. So what do I need to multiply this oxygen by to get 2? I need to put a 2 in front of that whole compound. However, that alters my hydrogen. So now I have 2 times 2 is 4. So I need to put a 2 coefficient for this hydrogen to get 4. So now I'm balanced. And I just am going to write out my word equation, which is water yields hydrogen plus, you can do a plus, oxygen. So again, it's not dihydride or dioxide because these are pure elements, so we name them just like every other element, hydrogen and oxygen. The only difference is if we write their formula, we have to write the subscript 2 because it is diatomic. Okay, let's do one more. Calcium carbonate. I have to write my formula. How do I write calcium? Ca. Oxidation number is 2 plus. Carbonate is from my polyatomic ion sheet. CO3, oxidation number is 2 minus. If I do my crisscross rule, they're going to cross. Remember my 2's, I have to simplify. So Ca, CO3. Okay, and then what does it tell me? I have 1 compound that has to be broken down. So that means I have a decomposition. I need to find my rule number. rule number 3 tells me a metallic carbonate decomposes into a metal oxide and carbon dioxide. So that would be rule number 3. So my metallic carbonate, calcium carbonate, is going to decompose into metal oxide. So what is my metal? My metal is calcium, and I know that because it is on the left side of the periodic table. And if its name ends in oxide, I know it has an oxygen at the end. Okay, I have to make sure I have my formula written correctly. So calcium's oxidation number is 2+, oxygen's oxidation number is 2-. They crisscross, they cancel out, reduce, so I just end up with CaO. And the last part of my product is oxygen. Oxygen is diatomic. I have to write it as O2. If I look and see if everything's balanced. Oh, and sorry, I looked at the wrong rule. So let's review. I'm sorry. Rule 3 says metallic carbonates decompose into a metal oxide and carbon dioxide. I had jumped down to the line below. So carbon dioxide, CO2. Carbon dioxide. Let's check and make sure it's balanced. I have 1 calcium, 1 calcium, 1 carbon, 3 oxygens, 1, 2, 3 oxygens. So I'm balanced. So all I need to do is finish filling in my word formula. So I know my rule sheet told me I was going to make a metal oxide. So really all I have to determine what my metal is, calcium oxide, and it also told me I was going to make carbon dioxide.